Hello guys, what's going on there? In this video, we're going to be working on some couple of machine learning exercises around Brulee ulcer, yaws, and I'm also going to do a model comparison between decision trees and logistic regression. Now, in my previous video, we created a model that can actually predict lymphatic filariasis, and that was based on logistic regression. But for the sake of this video, I've actually prepared exercises that is going to be very handful and useful on the course of doing a model comparison between decision trees and logistic regression. So I'm actually going to paste the exercises here. I've actually created a file, exercise.interactive Python notebook, and this is actually Markdown, and I'm going to paste the exercise that we're going to be working on right now. Now, essentially, this is what we're going to be working on. And what I'm going to do now is I'm going to segment it into various columns. What I mean by that is based on exercise 1 and 2, I'm going to move that to, okay, so yeah, so I'm going to put another Markdown, put this here, and I'm also going to put another Markdown. The first thing we're going to do right now is we're going to start running our code. And our first exercise here is I want to actually create a data set with age, hygiene. We've got skin lesions. We're going to create our target, infected, group, task, train our model, and also get our accuracy. Then the second, in our second exercise, we're going to create a model. Essentially, we're going to predict it with decision tree. We'll get the data set, the age, the household contacts, remain delay, target, infected group, task, and all of that. Then we'll do our model comparison with the third data set, where we're actually going to use both the first and the second data set to make our comparison. Now, what we're going to actually do right now in this code is that we're going to actually start by selecting our kernel, and of course, we're going to choose Python 3.13.3, and that should be fine. Now, to get started, the first thing we're going to actually do now is to import the libraries, packages that we're going to use for this particular exercise, and I'm going to start by importing pandas as pd. Then I'm going to actually import numpy as np. Get that correctly. Then I'm going to from sklen.model selection. I'm going to import trend test split from sklen. Now this is going to be for linear model. I'm going to import the logistic. Okay, sorry if I got that correctly. All right, so I think that's it. So I'm going to run it, shift enter, and everything runs. And the first thing we're going to actually do right now to get started now is we're going to create a random. That's np.random.seed. That's our seeded bot. We're going to assign it to 5. So what this does is that each time we actually it makes it reproducible, such that if we run this code again, it's still going to give us the same set of numbers or data set that it's definitely going to generate. Now, the sample size we're going to actually use here now is we're going to use 200 as our data sample. I'm just going to get that clearly. Now, to actually get started, we want to create a data set. We're going to actually say age that is equals to np.random.roundint. So actually going to set age from 5. That's going to from 4 rather to 71. That's 70. That's what it's going to act at, because it's not going to include 71. So it's going to be n. So the next one we'll actually do now is our hygiene. Right, so we're going to set it as np.random.choice. Okay. Then the choice method, then we're going to actually pass good and bad. Okay. Then as for the size is going to be equals n, which is 200. The next one we're actually going to set is our skin lesions, which is going to be a numeric integer. It's going to be of integer type, and that's going to be np.random.roundint. Then we have maybe probably 0 to 100. Okay, that was fine. Our size is equals to n. The next thing we're going to do now is, since we've actually created this, we're going to actually now create what we call our target. And how do we get our target? Our target is basically what is going to form as our ground truth, and that's the infected. I can actually say now we'll use the np.where function, where we say where. Now wherever age is less than, it's proper, it's less than 20, and then the hygiene, if I got that correctly, hygiene is equal to bad, and also and the skin lesion is greater than 50. Now what should it do? It should return 1, 0. Okay, so 1 stands for infected, 0 stands for not infected. That's else not infected. But basically what we're going to actually do right now is we're going to actually encode, we're going to try to look at get our data frame, and to do that we're going to actually say, since we're working with yours, we'll call it yours df is equals to pandas dot, we call it data frame constructor, and inside of this we'll pass a dictionary. I'm going to treat over age is going to be age as we declared, then our hygiene is going to be hygiene, and the next thing we have there is skin lesions is going to be skin lesions, and then our target, which is infected, that's the ground truth, is going to be infected. Now essentially if we actually want to print this, actually we'll see that this is our data frame and everything works very fine. And the next thing we're going to actually do right now is we are going to get we need to now, since we inspect this data, we'll see that hygiene is a categorical variable, which is something it's not numerical, it's not of string type, not string type, it's not of integer type. So essentially what we're going to actually do right now is to encode the what? We're going to encode the values, that are not of integer type. So that's where we're going to now have. Okay, so what we're going to do now is we're going to actually encode our values. So now we're going to have the yours df, so we'll call it, we're going to call it hygiene encoded. Okay, so we're actually going to assign that to yours df, then pass hygiene, then use the method map. Okay, now inside of this we're going to pass a dictionary where we're now going to say for good it's going to present as 1, and for bad it's going to present as 0. Okay, I think so that works. So basically we now have our encoded values. So the next thing we're going to actually do is what we call the features engineering. So we're going to actually set our data with the features and the targets. Okay, so what we're going to do, we're going to have our x, since machine learning works with that, say yours df, so we'll pass in another block there. So actually we're going to have age, we're going to have hygiene encoded, then we're going to have skin lesions. Okay, and I think that works fine. For our y, we're going to have our yours df, then we'll pass in infected. Now moving forward, without wasting much time, the next thing we're going to actually do now is we're going to now enter into training our model. So to get started with training our model, the first thing, training and testing and all of that, splitting, just getting our model set. So what we're going to do now, we're going to start by the first step is going to be to split our model. To split it, so I'm going to actually write that down. To split our, not model, that's to split our values. Okay, so to split our data sets. So I think that's much better. So I'm actually going to have x train, y train, and also say x test, rather, y train, y test is going to be equal to, so we'll call the method, train test method will pass x, y, we set our random state as 65, and the size is going to be equal to 0.2, or we can use 0.3. I think that works better. And the next thing we're going to do now is to train our model. So to do that, we're actually going to now call the model dot, we're going to call the model. First of all, call the object. We'll call the object. So this is going to be the model for, basically this is going to be the model for our, yells or whatever thing you want to call it. I'm just going to leave a model, and let me just call it logistic regression model log, or what, let me put our log model is equals to going to, so we call that. I'll actually put the maximum iteration, we set it at 1000. Okay, so to test it, we do our log model dot fit. Okay, so passing our x test, okay, to train. Passing our x train y train. So we run that, and that works fine, perfectly. So next one I'm going to do now is, I just want to take out that. I don't want that to be there. So I'm just going to return that. So the next one I'm going to do now is to now run our prediction. Okay. Now to now predict with what we've trained, with the model we've trained, we're going to actually say, we will call it y breadth is now equals to, say, log model dot. Okay, we call the predict method, predict and pass our x test. And that runs fine. So now to check the accuracy of the model, what we're going to do now is we're going to actually say accuracy, call it log, we can call it the log accuracy is going to be equal to, call the accuracy method, accuracy score. Okay, I don't think we've imported that, so we'll come back here, go to from sklen dot metrics, import accuracy score. Okay, so I think we'll have that imported right now. So now I say accuracy score, so that comes in. So basically we're going to pass in our y breadth and y test, okay, which is what we have. I'm actually going to print log accuracy. Okay, so we'll pass. Okay, so I think that works. So our accuracy is 96%. Okay, so if we actually want to convert it to probably to percentage, you can actually press .2f and all of that, but I think I'm going to leave it this way. Now the next thing we're going to actually do now in our second exercise here now is that we want to actually, before we do the model comparison, we want to get the want to use decision tree for leprosy infection prediction. So as usual, I'm going to actually run the code. I don't think I actually need to import pandas and all of that because I'm actually running it here. So I'm just going to set the random seed at 46, whatever. I'm going to set the sample here to 400. Okay. Now the next thing I'm going to actually do now is for the age, I'm going to say np.random.randint. Okay, so I'm going to pass in 4 and maybe 5 or whatever, 80. Okay, I think that works fine. And now for household contacts, it's going to be np.random.randint. Okay, so I'm just going to pass that in as between 0 and 2, size equal to n. I think I've actually forgot that. Okay, so pass the sample, size equals to n. I think that's fine. So the next one is going to be for treatment delay. I'm going to set it at np.random. I could actually see the choice. Okay, I'm going to pass that method, and probably we might say what counts as treatment delay. Probably say treatment delay in months. Oh, but let's leave it at strings, so we can see 0, 0, and 1. Okay, so still the same. And of course, size is definitely going to be equal to n. Now I just want to leave all of this in as strings. Okay, and what I'm going to do right now as integers, rather not strings, I'm going to want to leave it as integers. So what I'm going to do right now is I'm going to actually set our target, which is the ground truth. And actually to do that now, I can do that in many ways. So but I'm just going to now to get the infected, which is our ground, we call it our ground truth. Now what I can actually do now, I can still use a numpy function. So infected is equals to np.where. That's that method. Now I'm going to actually say wherever age is maybe greater than 40 and maybe probably maybe we could say maybe treatment is equal to 1. Maybe 1 is no treatment or whatever. I just want to actually keep that very simple. What it should return is 1 and 0. I think that runs fine. So next we're actually going to call we're quickly going to call our data frame. So this is leprosy. So I'm going to say lpdf is equal to pandas.data frame. So call the constructor. Okay, so inside of it, we'll pass in a dictionary. And this is going to be age. For age, is going to be age. For house, you can just say household contact. We can actually say household contact. And then basically for treatment delay, you can actually pass that inside of treatment delay. And for infected, it's going to stay with infected. I think I want to get that semicolon correctly. Now I can actually do LLP to look at our data frame, and everything works perfectly fine. So without wasting much time, we're actually going to go straight into assigning our x and y. So I'm actually going to say for x is equals to, it's going to be LP df, okay, and that's going to be age. It's going to be household contact. It's going to be treatment delay, okay, and for y is going to be equal to, probably we'll say LPDF, and that's infected. Now, one of the things we're going to actually understand right now is that we're going to actually use the decision tree, and in the next exercise, I'm going to also compare this to a model comparison between this and also the logistic regression for this. Now, but what we're going to do now is we're going to actually set our model. We're going to actually split. So for splitting, we'll say our user x train, we'll say x test, we'll say y train, we'll say y test is equals to, we call the train test split method, and pass x, y, random state is 23, whatever you have in mind. Our test size is 0.2. Now what I'm going to do right now is I haven't imported the model for training, or for the model for the decision tree model. So I'm going to actually do from sklearn.tree import decision tree classifier. Okay, so this is what we're going to be using for model. So I'm going to do for tree model. I'm going to call it tree model. Okay, that's here now. We're going to actually be training our model. We'll do training our model. Okay, so what we're going to actually do right now is for tree model, we're actually going to call this tree model as an object for decision tree classifier. I think we can actually pass our max depth to 4. Okay, so that's how much it can actually retrieve. So we can actually say here tree, we can actually call this object tree model dot, then we'll call the method dot fit. Okay, so we can pass in our, so basically we can actually pass in our x train parameter and our y train. I want to be sure we have that, so we're gonna run it, and of course, yeah, that works perfectly. Okay, I'm just going to put that again. And the next thing we're actually going to do now is to now predict, to actually perform prediction. So what we're gonna do now is we call it tree model. Okay, so we can say tree model dot predict x X text. So I think I can actually assign this to breadth, and then I think we can now print, we can print breadth, and this is actually going to give you an array. Okay, so this is what it has predicted. Now for us to actually determine the accuracy, I think I'm going to take that out. We can actually now do that's model accuracy. We can actually now do accuracy for the model, if I spell that correctly. Let me call this tree breadth so that it's easier to read. Okay, so the accuracy, we can say tree accuracy is going to be equal to. So we'll now see tree, so what I call it, accuracy score, then we'll pass the tree breadth and y text. Yeah, I think that works very perfect. So if we print our decision tree, so we can call this our decision tree accuracy following model prediction is, so we can pass tree arc. Okay, and that runs 1.0. Now another thing we need to understand is that we can also train all of these data sets with, we can actually determine the accuracy of the training. Okay, and to do that, what we can actually do to actually determine the accuracy of the tree, that's the decision tree accuracy, we can do something like, you can say, because we will say tree model dot fit, so we're passing on x and y. And now what this does is that it trains it with the whole data. So we can actually say now for tree accuracy, okay, that's accuracy of the tree. We can now say tree, let's say tree model. I think that's dot score. Then we'll pass. Then we can pass in our x and y. I think that works. So we can actually print tree. Okay. So this is actually the accuracy of the training. So I can call it tree training accuracy. Let's let me use that word. Tree training accuracies. Okay. So it doesn't confuse anybody. I'm just gonna copy that. Okay. Oh, I think that won't work because I misspelled something. Sorry, I wrongly spelled this. So let me just correct that. Okay, I think, oh, sorry. Okay, it works perfectly now, and that's it. Now, what we are actually going to do now is using the same data sets that we're actually going to now do some kind of, I'm going to slash this out. So we're going to do some kind of prediction, model comparison, and to do that, using the leprosy data set, using this last leprosy data set. So what we are going to actually do right now is, I think I'm just going to comment that. Okay, so let's use that. So what we can do now is, in order for you to understand everything I'm going to do, I'm going to say training for model comparison. Okay, so we're going to actually say x test, x train, x. Okay, let's spell that correctly, and I'm going to call this y. Now, what we want to do now is, I just want to run that again. Train the split. Okay, x, y, and random state. I can assign this as 0.4. I'll use 0.4 for my, that's 56. I'm talking about my test size is going to be 0.4. So 0.4 is going to be used to test my model. Okay, so I'm going to run that. Nothing happens. Everything is okay, and everything is all right. Now what I'm going to do now is, I'm going to now, we have the logistic regression model and also have the decision tree classifier. So essentially what I'm going to do right now is, I'm going to now test this. I'm going to use both models for this leprosy data set so that we can get the truth. Okay, we can actually ascertain the accuracy of both of them. Okay, now because if you actually look at this part, now you see that I didn't really use I didn't use the logistic regression here, but here I used the decision tree classifier. So, but let us just increase the sample size for the leprosy data set. So I'm going to just increase it to 1000. Okay, I just increase it to 1000. I'm just going to run it and everything works perfectly. And now what I'm not going to do now is I'm going to call for the log, that's for the logistic log, I'm used double this and logistic model, right? Is going to be equal to, I'm going to call the logistic regression. I just call this object. So I'm going to put the maximum iteration as 1000 as usual. Then what we are going to now do now is I'm also going to call the tree. So let me use T. Okay, so we'll get everything. T model is going to be decision tree classifier. Okay, I'm going to set the max depth to 4. I can just set it to 4. Now basically what we're going to do now is that we're going to actually use these two objects, okay, particularly these two models, to perform our training comparison, model comparison, okay, based on that data set. So what we will now do right now is we're going to actually save. Now, based on our training, we've already split it. So here now is training for the model. So the first step here, step 1 here was to split. Okay. Now, essentially, the second step here is going to be to now train the model. Okay. So I'm just going to say training the model. Okay. All right. Now, what I'm going to do right now is I'm going to now say for log model.fit. So this is for the binary logistic. So this is for the logistic regression, which is binary, of course. So say x train, comma, y train. Okay. I'm actually now going to do for the t model.fit. I think I'll just copy this, okay? So that I will, yeah. So I'm going to run that and everything works perfectly, okay? Everything works perfectly. This is for the decision tree and also for the logistic regression. Okay. Now the next one I'm actually going to do now is we are now going to run the prediction and the accuracy. And now what I'm going to do now is I'm just going to do both of them at once. And essentially, what I'm going to do now is for the accuracy. So I'm going to call this the log accuracy. Now, remember that whenever I want to calculate for the accuracy, what I usually pass in is the predicted and the predicted, that's the one we used to predict, and also the one that we have, right, for the ground truth. So essentially, that's the one that we split, the other data set that we split. So what I'm going to do now is I'm just going to pass everything inside of here, okay? And if you want me to split it, I can still split that, but I think that's just to save the lines of code. So what I'm going to do right now is I'm going to now save so here now the accuracy. So that's for the log accuracy. It's going to be, we'll call our log. Okay, that's our log model dot predict. Okay, so it's definitely going to be inside. I think what we'll do is we're just going to take it the same way. So the next one we're going to do now is we're going to work on our prediction. I'm just going to pass this, and this is going to be predict. Okay, but here now is going to be our x test. Okay, so the same thing is actually going to happen. 40 is going to be our x test. Okay, and then we're actually now going to call this is the predict method. Okay, to get that correctly, and everything still works perfectly. Now we've actually run this now. We're definitely going to get 2 arrays. Okay, so this is it. So that's it. So everything works very fine. So I think the next thing what we're now going to do now is now to predict, because we're doing an accuracy prediction. We want to actually predict, we want to do a model comparison. We'll now run our accuracy, which is going to now be, okay, I think I can just take out this accuracy, say x equals to name. Okay, so I just wanted to remove that. Okay, so what we're actually going to do now is that for our log accuracy, okay, it's now going to be, we'll call the accuracy method, and then we can actually assign this to probably we can say we can assign it to any variable, but we can still pass it inside of here. We'll now say our y test, so we can pass this in. That still works. And then for our T model, I'm just going to copy that here. So I'm just going to call it okay. So this is going to be our T model.predict. Okay. So what we can do now is we can now print the model accuracy for our logistic for the leprosy dataset. This, then we can now pass in okay, so the model accuracy for our decision tree classification for the leprosy data set. We can call it data set. Okay, so we can run that, and that's it. So you can actually say we have 0.966, which is 96% using our logistic regression, and 1.0 using our decision tree classification. So guys, I hope you actually found this video very helpful. You enjoyed every bit of it. And as usual, I'm just going to drop every code in my Git repository, and I'll see you in the next one. Thank you.